Hello, calculus fans. Welcome to today's lesson on infinite limits. I'm Jeff Luce coming to you from beautiful Northeast Ohio. Let's do it.
We're going to start out by finding the vertical asymptotes of f of x. There may be some, there may not be some. That's why the directions say if any. And we'll start off with number one. The first thing I try to do is to see if I'm worried about dividing by 0, and I can see more if I factor. So x squared minus 3x minus 10 will factor into x minus 5, x plus 2. The numerator does not factor, therefore there's nothing that will cancel away the x minus 5 or the x plus 2 from the denominator. They're both still going to be there, and for that reason, we will have two vertical asymptotes. One will be at x equals 5, the other at x equals negative 2. And obviously, I'd expect you to have both answers. All right, number two, find all vertical asymptotes. If you look at the denominator here, however, it's x squared plus 9. There is no way in the world that will ever be 0. Even if you plug a 0 in, you're going to get 9. And so since that can't be 0, and so therefore I can't divide the entire fraction by 0, I'm safe. There are no vertical asymptotes. That's simply all there is to it. Whoa, okay, I've kicked it up a notch now. This has to be factored. This is a great review of your Algebra 1. I try to factor the easier one first, knowing that I like to plan a lot of canceling in. That will make my life easier. So I go to the numerator. It's only a trinomial. I can see right away that I can factor out a 3, so I do so. That's going to leave me with x squared plus 3x minus 40, which in turn is going to factor again into x plus 8x minus 5. Now the denominator, of course, is 4 terms. That's going to be a little bit more problematic. They do all have x's in them, and they're all even numbers for coefficients. So I'm going to factor out a 2x. I'll go ahead and bring that 2x down, but I realize that that 4-term polynomial can be further factored by 4-term grouping from Algebra 1. So I group the first two together. I group the last 2 terms together. That negative or the minus belongs with the 4, so it's going to go in group 2. If you look at the first 2 terms, I can take out an x squared from them, leaving me with x minus 5. Okay, there better be another x minus 5 in the second part, otherwise it's not factorable or I goofed up. But yeah, if I take out a minus 4 or a negative 4, I do get another x minus 5. So excellent, those match. And since the x minus 5's match, I can factor it out. Put it down here, x minus 5 coming out, leaving me with just x squared minus 4, which I recognize as x plus 2, x minus 2. Difference of 2 squares, again from Algebra 1. Whew, okay. All right, factoring is finished. The x minus 5's will cancel, one from the numerator, one from the denominator. So instead of 4 vertical asymptotes, there will only be 3. And they are x equals 0, x equals negative 2, and x equals positive 2. So if this was a test or quiz question, I'd give you 3 points. I'd probably give you another point for the factoring, maybe make it worth 4 or perhaps even 5 points. And then I could deduct points for people leaving x equals 5 as an answer when they shouldn't. Also, a common mistake is for people to try to somehow say x equals negative 8 is a vertical asymptote. It's not. X equals negative 8 is simply an x-intercept. We make y 0, so you'd be crossing the x-axis there, but it's not an asymptote. Okay, so 3 answers, there they are. Our textbook's going to give problems like this. It's the same thing that I did, except we only care about what's happening at x equals 4. All right, one thing that's kind of cool about this is since they're mentioning x equals 4, they're sort of helping me with the factoring. They're kind of saying, yeah, you may want to try a 4. I'm like, okay. And sure enough, this does factor into x minus 4, x minus 2 down in the denominator. Wonder if x minus 4 is going to work up top as well. I'm going to take a shot at it. This other parentheses would have to be a 3x. I'll need a 7 to get the 28. It'll have to be a plus 7. Let's make sure the middle steps work. I get plus 7x minus 12x. Yeah, that works. Okay. So that's some quick factoring without needing the diamond method steps. And the x minus 4s will cancel away. Well, since they canceled, there is not a vertical asymptote at x equals 4. Instead, it's point discontinuity, also referred to as removable discontinuity, and that's what we want to say. If the question instead said, hey, what's going on at x equals 2, then it would be a vertical asymptote. Okay, we don't have to mention that because the directions simply said, hey, what's going on at x equals 4. So they're cutting down the work for us a little bit, which is nice. All right, let's try a similar question, number 5. Okay, what's happening at x equals 5? A removable discontinuity or vertical asymptote? Okay, again, we want a factor. Okay, we take out an x. And right now I can see that, yeah, there is an issue at x equals 5, but there is no way that I'm going to get an x minus 5 out of this. It's simply not going to happen. It doesn't take a rocket scientist to notice that. So because there won't be canceling, we will be left with this x minus 5 in the denominator, and therefore there will be a vertical asymptote at that location. All right, we're back to some one-sided limits here, as you can see. We've done this in the past. In number 6, we're approaching negative 6 from the left. In number 7, we're approaching 0 from the right. But this works its way into section 1.5, infinite limits. Let's see what's going on here. If you plug a negative 6 directly in, I'm going to try to not have to use the superscript. That would be negative 12 plus 3. It'd be near negative 9. But if you plug a negative 6 into the denominator, you're going to be dividing by 0. And I know this because I know that the denominator will factor into x plus 6, x plus 1. And plugging a negative 6 into that is going to get the first parentheses to become a 0. So no good. All right, so I do have to plug in negative 6.001. When you take the negative 6.001 and plug it into the numerator, you're still going to be very close to negative 9. In fact, moments ago, I don't know if I put the negative on the 9. I apologize. It should be right around negative 9. It's going to be negative 12.006 plus 3. That might as well be negative 9. That's negative 9.006. The closer you get to negative 6, the more zeros you have, the closer this is going to get to negative 9. In fact, I'll just call it negative 9-ish, which I realize is not completely mathematical, but yeah, it's okay. We'll go with it. If you put the negative 6.001 into the denominator, you're going to get negative 0.001 here, which is really the big factor. Here you're going to get something really close to negative 5. I'll go negative 5-ish. Air quotes. What's going to happen here is you're going to have a number near negative 9. But here you're going to have a negative times a negative, which is a positive number, but it's going to be near 0. And so negative 9 divided by something that's near 0, but positive, is going to be negative infinity. Now, I'll be quite honest, that's a bit of a sloppy explanation. Some people aren't going to like that or they're not going to buy it. Other people are like, hey, that was cool, I'm good. Let me backtrack for that first group of people I referred to. Let's take the ish out of my explanation. If you plug in the negative 6.001, you do get negative 9.006. In the denominator, you're going to get negative 0.001 times negative 5.001. If you multiply these two terms together in the denominator, you're going to get 0.005001. If you were to slide the decimal point over 6 spaces, and you were to slide this over 6 spaces, you'd need 3 more zeros to get to 6 spaces, you'd have negative 9 million and change up top, divided by 5,001, which is roughly negative 1,800. Now, I realize that negative 1,800 is a far cry from negative 1,000,000, but what if instead of negative 6.001, what if you put in negative 6.0001? Well, you'd be closer to negative 18,000. And the more zeros you put in here, the more zeros you're going to get here. And I think it's easy to see where you're headed towards. The closer and closer and closer you dare to get to negative 6, the closer and closer and closer your answer is going to be to negative infinity. And that is the limit. Remember, the limit's what you're approaching. It's not what actually happens when you get there, because you can't get to negative 6. You're not allowed to plug it in. You'd be dividing by 0. All right, number 7. A little bit different because we have trig. It's the tangent of 0 from the right. So it's like the tangent of 0.01. Well, 0.01 radians would still put you in quadrant 1, but you'd just barely be in quadrant 1. It's like kind of hard to make an angle like that small, that skinny, but it's right there. But this is going to be positive and very close to 0. So you're going to have like 10 over point, something like that. The closer and closer and closer you got to 0. Yeah. And if you move this decimal over and you move this decimal over the same number of places, I think it's very clear to see that you're headed to the answer of positive infinity. Of course, we can work infinity in different ways as well. I can let the limit as x approaches infinity come into the mix. Again, this is a bit of a review of pre-calc. Remember that if x is heading towards infinity, and you plug infinities into all these locations, what's going to happen is the bottom of the fraction is going to grow faster than the top of the fraction will. And you may remember from honors pre-calc, if the bottom grows faster than the top, the answer is 0. Remember, we talked about end behavior as well. Y equals 0 would become a horizontal asymptote in this case. If the numerator has a larger degree, which in this case it does, 3 to 2, and the numerator grows faster, the answer will be infinity. If you're not buying into this, here's what you can do to formalize it a little bit. Let's go back to number 8 just for a moment. What if I took all 5 terms and I divided them all by x? This would become just a 5. This would be 15 over x. And the same thing would happen down low. This would become just x plus 11 plus 28 over x. You can see that x is heading towards infinity, so if you park an infinity where the x's used to be, it's easy to see that this is pretty much 0. 15 out of infinity. If you got that on a quiz, man, I'd start crying. 28 out of infinity is not a whole lot better. Those are pretty much just zeros. But you still have an infinity down here, plus 11, just for good measure. So you have 5 over infinity. That's 0. That's approaching 0. Which is why if the denominator has a larger power than the numerator, it's going to be 0. Whereas if the numerator wins out, like in number 9, it's going to be infinity. What if it's a tie? I'm so glad you asked. What if you have something like number 10 where it is tied? The degree of the numerator is 2, the degree of the denominator is 2. All you simply do is you strip off the coefficient of the largest powers, 6/8, which I would like you to simplify to 3/4. This thing will head towards 3/4 as you get out to infinity, or in this case, negative infinity. That does not change the answer because it's negative infinity. It's still 3/4. And again, if you divided everything here by, let's divide everything here by x squared this time, like so. I think it's easy to see if you put a negative infinity in where all the x's were, all four of these terms are just zeros or negative zeros, which is the same thing. You're just going to be left with 6/8. So in short, if the numerator has a higher degree or higher power exponent, then you're going to get some sort of an infinity, maybe negative infinity, depending on the original problem, whether the negative's on there in the limit. If the denominator has a larger power, it's going to head towards 0. The limit will be 0. And if it's a tie, like number 10, you ignore anything that's not the largest power. You just go with the degree or the largest exponents. You strip off their coefficients and reduce. Done. So again, a bit of a review of pre-calc. Finally, last but not least, number 11, you got the numerator winning out. Clearly, it's 3x to the 4th, and this is only 12x to the 1st. We don't need to look at anything else. So we know that the answer is going to be some sort of an infinity because the numerator is winning here. But is it infinity or negative infinity? That's the big question. And in this case, it's going to be negative infinity. And here's why. 3x to the 4th is 3, and then x times x times x times x. So there's 4 of them. 12x would be 12 times x. Imagine if all the x's were negative infinities. Oh, well, of course, one of these negative infinities can cancel, but there's still 3 of them left, and we know that negative times negative times negative is still negative. So the answer there would be negative infinity. If this had been 3x to the 5th, however, and we had gained one more negative infinity up top, let's just pretend that there's one extra. Now you've got 4 of them, and that would turn the answer into positive infinity. So the rule here is if you're heading towards negative infinity and the numerator is winning, it has a larger power, a larger degree, you want to subtract the powers and see if the difference is even or odd. In this case, it was x to the 4th and x to the 1st. 4 minus 1 is 3. I knew that I would end with 3 negative infinities. That's an odd number of them, so the answer was negative infinity. Let me go back and actually leave the answer correct. I always tell you as a teacher, never leave anything incorrect on the board because somebody's going to copy it. All right, so that's the correct answer. If you subtract the powers and it comes out to be a difference that's even, then this will turn positive infinity, even though you were plugging a negative infinity in. On the earlier examples, if I was heading towards positive infinity, I wouldn't care about subtracting because these would all be positive infinities anyway, and positive times positive times positive is going to be positive no matter how many you have on the numerator and denominator, whether they cancel or not. No worries. Okay? All right, we've reached the very last example from chapter 1. Sketch a graph of the function y equals f of x that satisfies all the stated conditions. Include any asymptotes. All right, on a test or quiz, and this will show up, I promise, this would be a great 6-point question because I could give you partial credit for each colored step that you successfully do. And the nice thing is that you can avoid a chain reaction. Just because you missed the red step doesn't mean you're going to miss all the other colors. So, excellent. I am going to color code this as I explain. I'll start with the red. It says the limit as x approaches negative infinity of f of x is 3. If I'm heading out towards negative infinity, I'm actually creating a horizontal asymptote. All right, so as I head out to the left, I'm going to get closer and closer and closer to a height of 3. That's what that says. All right, awesome. Now, I could have come from the top. There's nothing to say that I couldn't have made my picture look like this as well. And they're both totally fine, but obviously I have to pick one of them, so I think I'll pick the one that I used first. So I have to approach the point -1, 2, which is right there. Now, it says x approaches -1. It doesn't say what side I'm coming from, so I have to approach that point from both sides. Both from the right and from the left. I don't really know what I'm doing. I mean, I can kind of wiggle around. Let me connect this. Now, of course, some people are going to jump all over me and say, you crossed the asymptote. And I have to tell you, this blew my mind when I first learned this, but horizontal asymptotes are allowed to be crossed. Wait, what? Yeah, it's true. Horizontal asymptotes can be crossed in the middle as long as eventually the function becomes asymptotic out by the ends. I didn't know that until I was in college. Now, of course, you can never cross a vertical asymptote, because if you cross a vertical asymptote, you're doubling back and then you're violating the vertical line test. But horizontal asymptotes, they can get crossed in the middle as long as eventually the graph agrees to behave itself and approach and never touch again. It's like, wow, that's bizarre. I never knew that. All right, so that part is also correct. All right, now I make my way to +3, and clearly I'm going to have an asymptote there. You can see that when I approach +3 from the left in green, I'm heading towards infinity. But as I approach +3 from the right-hand side, I'm heading towards -infinity. So that's going to produce infinite discontinuity at x = 3. So again, I'm heading towards 3 from the left. I have to go to infinity, so I have to head up. Like so. Okay, that looks good. But when I head towards the same dotted line from the right, I'm heading towards -infinity. So I have to drop. All right, so far I have 4 out of 6 figured out. Next up, when I head towards 5, I'm heading towards the point 5, -2, which is actually right here, so I'll just go there. Again, I can put a little wiggle in there if I want. I can be a little clever. And since there is no plus or minus, there's no superscript there, I have to hit the point 5, -2 from both sides. I got to come out the other end. Now, this dot could be filled in. It could remain open. It's completely optional. There's no right or wrong there. And finally, last but not least, let me put a check mark on that. The limit as x approaches infinity is -4. Again, that's going to be another horizontal asymptote. See, right off into the sunset, approaching -4. It's like a plane coming in for a nice soft landing. Never actually touching the line y = -4, but approaching it. And that's it. We got all 6 parts correct. Like I said, there's some flexibility. You know, you can make your graph more straight. Some people will make theirs more wavy and crazy. Just don't get too crazy. Don't get cocky. I have some people that, like, for the red section, they're coming along and they know what they're doing. They got their asymptote heading towards 3. But in the middle section, they're like, oh, look at that. You know, and they reconnect. I'm like, dude, you just violated the vertical line test right here and here. That's not a function anymore. And so you lose points because you got too obnoxious. So, you know, just make sure that you're not doing anything too crazy here. There, that's more like it. And that is it for chapter 1. All right, hope you guys understood all that pretty well. That's limits. The reason we do limits is because calculus, when we learn about the derivative in the next chapter, is based on limits. And so it's good to have a solid, strong foundation. All right, catch you guys later. Take care.